My name is Patrik Rokyta, and I'm the Vice President of Architecture and Future Technology at Titan.ium Platform. That is a company formerly called NetNumber. And during the next 30 minutes, I will elaborate on the key aspects of building and running 5G core with success. My team and I have been involved in a cloud-native transformation since 2018. We've gone through many fails and successes and collected valuable insights that I'm happy to share with you. So the next slide, please. So the temptation, especially when you have a working product that can be already deployed as a virtual machine, is naturally to deploy it as a monolith, also in the cloud-native environment. And this approach is called lift and shift, and definitely not something the industry wants. So moving monoliths around is difficult, and most of the processes defined for cloud-native solutions, they do not work well with monoliths. So let's quickly recap on the characteristics of a cloud-native solution. And with this, we can go to the next slide. So to qualify for the 5G race, you need to start in the right place. And the right place is having a cloud-native solution and the associated processes available and supported. And 5G is deployed as a distributed architecture. So depending on your product, you may face the global data center, the regional data centers, or the mobile edge, or even the enterprises as the target for your deployed product or solution. So as the target deployment location. And optionally, your product may be deployed across a number of availability zones of a selected cloud infrastructure provider. It really depends whether you deploy on-prem or in a public or private cloud environment. In any case, you will need to deliver your product to the target place and get it deployed there. And during this phase, you may already observe resource limits that may be no problem for cloud-native solutions, but may be a big problem for monoliths. Examples include, but sure are not limited to, the data transfer speeds and the CPU and memory limits on the deployed compute. And for these reasons, you're always better off with cloud-native solutions. Cloud-native solutions consist of small pieces of software called containers. Designed correctly, the services delivered by the containers can be distributed across multiple compute nodes and are therefore highly scalable. Example of the services include the 5G network functions, like the network repository function and RF, but also specialized platform services, like the service mesh controller. The orchestration of the container-based services is delivered by the underlying container service layer that we will explore in the next step. So the next slide, please. On this slide, and of course, containers, they need container services to run. So you see container services being deployed on top of your target infrastructure that can be bare metal, virtualized, or as a service. Examples of as a service infrastructures are the hyperscale infrastructures from Amazon, Google, and Microsoft as examples. But there are also other telco-based infrastructures that can be delivered from traditional telco suppliers. On the right, you see what you already know from the virtualization approaches. You see the infrastructure management, which means the management of the virtualized resources, whether it's relating to storages or to networking, load balancing, and so on, keys, identity. And now what comes as an add-on in the cloud-native world is the container services on the left. So if the operator asks, yeah, we now need to do something in addition to run containers on our infrastructure, then the answer is yes, you have to. And there are several container services that must be observed. And one of the most important services, besides the container registry that provides for the storage of your container images, is the container runtime and orchestration. And that's because with containers, you have simply too many moving parts and you cannot manage them manually anymore. You need a automated environment that does orchestration and management of the containers automatically, and the most well-known environment for this is Kubernetes. And then in the Kubernetes environment, you can manage your workloads as well as the container services themselves. So you see example of the container services on the left side. again, dedicated to storage, networking, service discovery, and so on. But the most important message I want to mediate to you is there must be a seamless interaction between the container services on the left and the infrastructure services on the right. Without such seamless interaction, you will not even be able to demonstrate the benefits of your cloud-native solution simply because the underlying layer will not work properly. And it's still surprising, or it's surprising that 4 years after we started cloud-native transformation, there is still a lot of discussion between the interaction or seamless interworking between the container services and the infrastructure services. The discussion topic is mainly about the responsibility. In the DevOps model, in the telco world, we see a split of responsibility. We have delivery from the suppliers into a target environment that is owned by the operator or cloud provider. And therefore, the DevOps doesn't run on the same system. Yeah, there's a split, delivery, and then deployment and operations. And therefore, the agreement on the responsibilities within this split of responsibilities is quite difficult. And the key message here is that the best is that the cloud provider takes the responsibility for the entire container services. We still have discussions that the suppliers have to bring some of the container services into the cloud-native environment. But because the deployment and proper runtime of the container services may need adjustment of the underlying layers, including the Linux kernel, for example, it's really difficult with a split responsibility to finally identify who is responsible for the overall SLA of the cloud infrastructure and the associated services. So again, integration of these services is important, and defining the responsibility is a key. With this message mediated, let's move to the next slide and see how cloud-native products can be built. And building cloud-native products differs from building the traditional telco products quite a lot, simply by the increased amount of third-party software that is integrated into your cloud-native product or solution. And to keep the software quality up and the associated costs down, you need a lighthouse that guides you during the selection of the third-party software. And the Cloud Native Computing Foundation can act as such a lighthouse. The CNCF is an open source vendor neutral hub of cloud native projects that are grouped into different categories. And each of these categories for each of the projects delivers valuable information, such as the project maturity, the size of the community behind the project, the funding, the latest commit and release, the license, and more. And all this information greatly helps in identifying the most viable solution for the area of your interest. And well-known examples of the CNCF graduated projects are, of course, Kubernetes, etcd, CoreDNS, and Helm, which are the before-mentioned container services, including the de facto standard packaging framework for Kubernetes. You may decide to obtain professional support for selected or critical functionalities of your product in such a if such functionality includes the open source code. And for less critical functionalities, you may rely on the community support or even build a support team within your organization. The decision is mainly driven by considering the trade-off between the ability to properly react to incident reports observed in the field during the deployment and the associated cost of support. Then building software in a systematic and cost-effective way needs development environment and tools that provide for automation and continuity. And then on top of it, your company needs to implement a proper development strategy and methodology. And a great example is a software development lifecycle process that implements the agile methodology. And the agile methodology gives you a better control of your product increments, improves the project predictability, and with this also the stability of your roadmap. So with the proper deployment strategy or development strategy and methodology and tools in place, you can now build your own code in the areas of your core competency and knowledge, and integrate third-party code where in-house development is not viable or possible. And whether a platform service, a network function, or protocol stack, or something else, the code, build, and test steps, they are executed continuously till the targeted product or the solution increment is ready for a release. You know this process being referred to as the CI/CD process. So we could now start elaborating on the delivery process, but before doing so, let's have a look at the security-related aspect. And with this, we move to the next slide, please. So the ultimate goal here is having security natively built into the software development process and to integrate the relevant security measures at each stage of the process. So how does it work? At first, security needs to be thought of during the design phase of the functionality. So this includes the profiling of the technology to be used and the identification of the attack vectors. And with this, you can identify the best practices applicable to the various areas during your DevOps cycle. And there are examples of these practices. Let me mention the 12-factor application framework, the Open Web Application Security Project that addresses the most common web-based type of exploits, the golden security rules of computer security defined by the CIS and of Center for Internet Security, the system hardening requirements that can be based on the benchmarks defined by the previously mentioned CIS, Center for Internet Security, and last but not least, the GSMA Network Equipment Security Assurance Scheme, NESAS, that I will come to later on this slide. So when integrating third-party software, something that everybody is doing nowadays, you want to perform a continuous software composition analysis to track the licenses of the third-party libraries that you use in your software. And with that, you identify licenses that might not be suitable for your type of business or that are simply not allowed in the target deployment. And note that some of the open source projects, they change the license as they go. And for sure, with that, it's needless to say that the software composition analysis should be integrated into the CI/CD pipeline and executed continuously as you go. And yet another important security measure is the static application security testing, that is also known as the white box testing. And here the goal is to identify early on the potentially known common vulnerability exposures, CVEs, that are affecting the relevant third-party libraries you are using. And during the static application security testing, the source code is analyzed to find security vulnerabilities that make applications susceptible to attacks. And the known common vulnerabilities exposure severity is scored based on a common vulnerability scoring system, CVSS. So there's a scoring system on each vulnerability that is known. And this scoring system will help you to prioritize the work you need in order to resolve the detected vulnerability. So you don't need to work on all of this. Again, there is a score, and you can start focusing on the most critical one. As an option, you can for sure involve external companies to assess the security posture of the application. And the associated method that I want to mention in this content is the penetration testing. And the penetration test, they simulate a variety of attacks that could threaten your product or even your business. And with the right scope, the penetration test can dive into any aspect of your system. So it's very valuable. Finally, or in the next step, you take the result of the penetration test combined with the benchmarks offered by the Center for Internet Security, CIS, I already mentioned that. And by considering any feedback from the field, from your customers, you harden your system in the area of concern. And this can include the operating system, the container engine, the Kubernetes cluster, and more. One last statement to the security aspects. You can consider the GSMA NESAS audit for compliancy of your software development lifecycle. That also includes the product validation. And last but not least, the vendors see an increasing number of requirements targeting the sustainability of the company and its product portfolio. So we also need to be sustainable. Energy use, handling of waste, greenhouse gas emissions, all these will become more and more important. The next slide, please. I already mentioned that part of the cloud native stack are the platform services. And this is yet another area to be very well aligned between the cloud provider, means the operator, and the suppliers, the vendors. And here I mentioned the vendors in case the operator's solution involves multiple vendors. So platform services is something that greatly help in providing visibility and management end-to-end of the deployed solution, of the deployed network service. They provide mainly optional solutions that will ease the runtime of the deployed solution. But some of the platform services, they are also directly involved in the signaling. And depending on your deployment model, on the architecture, whether it's zero trust architecture, where every vendor has its own Kubernetes cluster, or whether multiple vendors share the same cluster, the alignment on the platform services is less or more difficult. The trick here is, or the challenge here is, that some of the platform services can be installed only once on the cluster. An example of it is the custom metrics API server. You know it as the Prometheus adapter. Only one instance of such server can terminate the custom metrics API. You cannot terminate the same API on multiple instances. Doesn't work. So if 5 vendors bring their own custom metrics API server into the target cloud, that will definitely clash. And avoiding the clash is really crucial to have a stable and working 5G core system. So what does the operator and the vendors need to do is to align on the platform services they need or require. And then there will be a responsibility for each of service, either on the operator side or on the vendor side, to deliver such a service. Usually, what I want to content to the audience is that the operator should define a set of platform services that all vendors delivering solutions into the cloud environment of the operators need to integrate with. And then, of course, the vendor can bring its own additional platform services that are needed to run the vendor solution. Let's go to the next slide, please, and elaborate on the delivery process. So now, when we have built the software, whether it's the network function or a platform service, as we elaborated on the previous slides, let's see how to deliver this software to the operator's premises. And for sure, in the start of cloud-native transformation, many people tend to upload the released software to a Dropbox and inform the customer to pick the software from there. This may work in the start where there is an interest to get the functionality running on the target cloud-native infrastructure, but sooner or later you need to move to the exploration of the processes for their efficiency. And the delivery process is one of the processes that will drive the deployment economics. So definitely needs a deeper look, and simply due to the fact that the manual delivery doesn't scale very well without scaling the associated resources, and scaling the resources together with the with scaling your capability to deliver is definitely not a good idea. It will not work forever. It will not work to unlimited scale. So what you need to go is to go to automated delivery that provides for continuity and scalability. And here you can finally separate the rate at which the cost grows from the rate that comes from the increasing number of deliveries. We refer to this separation of rates as the hyperscale economics. You can elaborate on it offline, but this is something that the telcos need to start to pursue. This linear growth of capabilities with linear growth of cost will not simply work in cloud-native environments. And we also see that many customers are saying, yeah, we more rely on the manual processes with methods of procedures and so on, because machines can be wrong. They do something we don't want. Yeah, it's true. The machine executes a code, so the code can be flawless or it can be full of bugs. So it's the same machine that executes the ether code. But again, too many moving parts create the need for automation. The next slide, please. Once we have our released artifacts delivered to the customer, to the operator, the deployment process will kick in. This is nothing that the vendors like Titan.ium Platform LLC can influence a lot, but it's definitely need to understand the end-to-end aspects, because only with a team spirit between the operator and the vendors, you can create highly effective and a resilient 5G core. So on the deployment process side, the vendor, depending of the level of trust, can be zero trust, it can be some trust or full trust, needs to scan the delivered artifacts. And this includes the integrity check. Has nothing to do with the trust to the supplier. Something can get broken on the way to the vendor's repo. You need to do authenticity check whether the software is really the one that you intend to deploy. And then, of course, up to the operator or to the customer, the vulnerability scan, the dynamic application security test can be executed or not. That's the black box testing. Finally, the artifacts are distributed across different repos. I distinguish 3 different types of repos: the container registry, the chart repo, and the artifact repo. Artifact repo is something like configurations, key stores, and so on. And then everything goes automatically into the continuous deployment process that utilizes different measures and vehicles to deploy the internet solution continuously on a lab system, on a pre-production system, and production system. There are validation steps between observing failure metrics to proceed from the one stage to the other stage. And finally, the system shows us in the production system and operates as expected. What I want to highlight here, that this is quite a new process to telcos that's been adopted from the IT world. It's making the telcos transition to technology companies. So therefore, the equation GitOps, which is the methodology and the processes for the deployment of cloud-native applications, together with a continuous deployment process, is something that defines the technology company. And some of the telcos will do the transition, some of them will not. So let's move to the next slide. The next slide elaborates on different aspects of the operations. I will not touch all of them. I just want to share my opinion that many of the gaps between the vendor's minimum viable product and the expectation of the market are revealed during the operations. It's quite straightforward to design a software for a dedicated functionality and get it deployed somehow. But then during the operation that involve lot of tasks and operations, you see them listed on the left. Many gaps are revealed that may slow down the acceptance phase, or it may basically make the operation of the deployed solution complex and expensive. So operational capabilities at the system level, I'm not talking about the operational capabilities at the communication service level, understanding and pursuing the economics of these operation capabilities is a key to success. And what I want to also highlight is that there is definitely a difference between the expectation of the innovators and the early market compared to the rest of the market. So there is this curve that exposes this chasm between the early market and the majority of the market. And again, the expectations and requirements in each of the markets left of the chasm and right of the chasm are different. So yeah, operational capabilities need to be in place. Again, it is a driver for the economics of the deployment of the platform that you deploy, and therefore understanding them is a key. Let's go to the next slide, please. What the area that is sometimes left untouched is troubleshooting, usually collecting traces, collecting logs, and discussing back and forth to resolve an incident is the way most of the parties proceed in this exercise. But in the cloud-native environment, troubleshooting is a little bit more complicated. Of course, it costs time and resources as always, and can be complex and needs to be fast, especially if SLA is concerned due to a service degradation or service outage. But the challenges in cloud-native environment that come on top of what we know from the traditional telco world include the fact that there are too many moving parts, or not too many, there are many moving parts, containers, and they have resources isolated into the namespaces. You cannot access them easily because of security measures applied to the isolation of resources. Most of the traffic and data might be encrypted. Yeah. It might be harder to get vendors involved when higher security measures are in place around the solution, around the cluster, around the demilitarized zone. And of course, as always, post-mortem tracing may not reveal the problem. You need to basically catch the problem where it happens and when it happens. And therefore, there are important measures to help in making troubleshooting effective and fast. And you see these measures on the right. So there are facilities providing for end-to-end visibility and monitoring. Many troubleshooting measures like self-healing are delivered natively by Kubernetes, so they shall be definitely utilized. And of course, then, as we know from the traditional work, we want to collect OEM data, put thresholds that are deployment specific on important KPIs, and then observe these KPI threshold crossing to generate alarms or to apply automated scripts that may be a result of artificial intelligence or machine learning or some sort of it. What I would like to contend is that in cloud-native environments, it's always a good idea to let the vendors participate in the troubleshooting on premises, for instance, when there is an available lab system where the vendors can hop in and elaborate on the incident the operator is observing. Good, we can move to the next slide. And I can only conclude that we have elaborated on the different aspects that help in successfully building and running 5G core, but let's still recap. Yeah. So your product or solution must be cloud native. Yeah. Cloud native means that your solution is portable, can be easily moved between different types of infrastructure, and apply processes designed for cloud native solutions such as GitOps. The security aspects must be observed during every step of the development, delivery, and deployment process, and need to be natively built into the process. As mentioned, due to the many moving parts, automation is key to drive the economics of your development and operations. And we see an increasing number of requirements addressing the sustainability of the company and its product portfolio. I mentioned that. And finally, there is no need to invent any technology in isolation. My suggestion is to team up with your customers, partners, and the open source communities to identify and pursue the future technology, and also aim for compliance of your processes with the associated standards. Yeah, definitely, whether it's GSMA NESAS as an example or something else. For those who do not know Titan.ium Platform, Titan.ium Platform LLC, formerly NetNumber, I mentioned that, is a communication solution supplier with a portfolio that comprises more than 20 products in the signaling, security, routing, and private network space. The entire product portfolio is being migrated to cloud native to enable intergenerational network transformation that is more than just 5G. And by having this message mediated, I have reached the end of the session. I hope it was valuable to you to see how 5G core can be built and what pitfalls must be observed, what tasks need to be addressed. And if you have any suggestions or comments, please address them to me. I will be happy to answer them. And with that, thank you very much for attending. The closing slide, please, and over to Annie.
Okay, so we have several questions for you here, Patrik, but we've just about run out of time. So I'm just going to take one of them, and then we will pass the other questions on to you via email, if that's okay.
I can also answer them live during the next sessions. Yeah.
Okay, so behind the scenes live. Okay, yeah, okay. So should we just ask the first one, which is, have you any experience of how easy it is to start building your own code in cloud native? I would think the answer is yes.
Yeah, we have the experience, definitely. The question is whether you have an existing product or not. When you have an existing product, you are basically porting your product and transform it to cloud native. And here you rather deal with the decomposition of your software, of your monolith into different pieces called microservices or containers. Yeah. So you usually keep your software stack, yeah, which can be Java or C, or some traditional language, and rather spend your time with decomposition. If your question means the greenfield development of your cloud native applications, yes, we have this as well. And here my suggestion would be that you either embrace the software stack that you are used to, or you hop on the stack with that Kubernetes was implemented with, which is the Golang language. Yeah. And with Golang and across the entire community, cloud native community, you find a solution for most of your problems on a GitHub. Yeah. So by observing the licenses correctly, you can reuse these solutions that already exist in your lab, experimental, or even production environment. So again, it's either decomposition with your existing software stack, or it's a green development with a new stack. And here I would use the native software stack the Kubernetes is developed with. You can even go with beyond that. And when you have performance concern, you can switch to software stack that based, for instance, on the Rust, yeah, as an example.
Well, Patrik, thank you. We'll leave you to take the questions offline. I thought that was really interesting. And it's been interesting as well to note how much GitHub is cropping up all over the place, particularly as this year has advanced.
Yeah, great community, great work done. Yeah.
Thank you very much indeed. Always a pleasure.
Thank you, Annie.